All right, so welcome back to Clever Minds, still on quadratics. And in today's class, we'll be looking at the minimum and the maximum values of y equals ax squared plus bx plus c, right? Good. So one thing we know is that this um, equation, y equals ax squared plus bx plus c, we know that at the lowest point of um, a parabola, let's a parabola like this, at the lowest point, we know that the a is greater than 0. That is, the a here is greater than 0, right? Good. So that tells us that when a is greater than 0, the lowest point of this parabola or this equation is called the minimum point. The minimum point. Minimum point. Why the in a parabola in this shape, you have the a is less than what? 0. So at a less than 0, we say the highest point of this parabola is called the maximum point. Maximum point. Right? Good. So now, these are just elementary knowledge on how to determine the minimum and maximum points in a parabola. Right? You know, a parabola is a curve. So this occurs when x is equal to negative minus b over 2a, right? Good. So we have x equals negative b over 2a, gotten from the line of symmetry of the what? Parabola. Are you there? Good. So at what point of x, at what point or what values of x are the minimum and maximum values attained? So this can only be found, the values of x at which the minimum and maximum values can be attained can only be found by method of what? Completing the square. So let's see that. Let's see that method of completing the square. So now, when we have y equals y, or we have ax squared plus bx plus c, right, is equals to y. What that implies is that by method of completing the square, we can factorize out a, and we have a into x squared, right, plus b over ax, right, then close bracket, plus c, which is equals to y. Good. So from there, we are able to see that by the time we half the coefficient of x, which is b over a, that is, we divide the coefficient of x by 2, we have b over 2a. Yes. When you divide the coefficient of x by 2, you get b over 2a. Then we square it. That gives us b squared over what? 4a squared. So we add it to this expression. Are you with me now? This expression, what expression in the bracket? X squared plus b over ax. Remember, what are we trying to find? We are trying to find the values of x for which this equation has a maximum and a minimum, right? Good. Values of y. So now we have a into x squared plus b over ax plus b squared over 4a squared, right? Now, in order to make it look like this expression exactly, because this, what I've just written now, is not exactly like this. Are you with me now? So we need to subtract b squared. It's just a technique or a trick, a mathematical technique or trick in order to make it the same. Good. Then we put back in brackets. Then we say plus C. Do you understand? Good. So from there, we are able to see that A into x squared plus b over ax plus b squared over 4a squared minus, instead of me right now, I'll use this a to divide one of the a square here. So I'll just put this in brackets, then I'll bring this out. Negative what? B squared over 4a plus c. Meaning I've used this a to divide this 4a squared. I didn't use it here, so I still have it in this expression. Do you understand? Good. This a has cancelled this a, so I have this left. Now outside the bracket. Good. So now from here, we are able to see that this has become a perfect square, isn't it? Good. So I'm able to write a into what? X plus b over what? Over 2a all squared. Remember this? It's the same thing. This is it here. So minus what? B squared over 4a plus c. Are you with me, guys? Good. So now, the next thing for us to do is to find the LCM of this. A into x plus b over 2a squared. Then that gives us 4a, right? Good. Then we have minus b squared plus 4ac, right? Good. You have the negative. Are you there? Which I can reconstruct by writing this a into x, or I'm restructuring it, squared plus 4ac minus b squared, right? All over what? 4a. So now, this expression underlined. Now, I'm going to underline an expression. Watch me. This expression underlined is always positive when the value of a, or this a, is greater than 0. When the value of a is greater than what? 0, it's positive. That is, by that, when we take the square of any real number, it will always give us, it's always positive, right? Good. It's always a positive real number. So we can conclude that the minimum value of y is attained when this expression underlined, that is what expression? The expression x plus b over 2a is equal to 0. And what does that mean? That gives us x equals negative b over 2a. So this is what I call the line of symmetry the other time. Can you see how it has been obtained? So when this expression is equal to 0, the expression in the bracket is equal to 0, right? Then the minimum value is therefore this. That is, this is the minimum value of y. Let me bring it out for you in the red ink. Here comes the minimum value of what? Y. Because minimum value of y will be when a is greater than 0, which is the what? Highest point. Are you with me now? Good. So that's the sorry, did I say highest point? Lowest point. Actually, the minimum value of what? Y. That's the lowest point when a is greater than or equals to what? 0. So here is the minimum value. I call it y minimum. That is when a is greater than what? 0. This becomes the minimum value of y. Do you understand that? Good. So similarly, if x is, if a actually, if a, I'm with you, if a is less than 0, what that means is that the expression underlined will be negative. Are you with me now? The expression underlined, that means once a is less than 0, what are the values of a less than 0? -1, -2, -3. So it changed the whole symmetry of this expression and to make it less than 0. So once when a is less than 0, we say that the expression underlined is negative. Yes. And y is attained when the maximum value is attained. Y will attain its maximum value when the expression in the square brackets, that is this expression x plus b over 2a, so x plus b over 2a is also equals to 0. So we still have x equals to what? Negative b over what? 2a, which is still the same line of symmetry. So but in this case now, it is when a is less than equals to 0. So now, so this now becomes again y maximum. Are you with me? When a is less than what? 0, and when the expression is equal to 0, the expression in the what? Bracket here, this expression here is equal to 0, right? So if you don't want, if you don't understand, this is it. For example, a is less than 0, we take -2. If the expression is equal to 0, expression in the bracket is equal to 0, you know that means that's 0 squared, right? And what would that give you? -2 times 0, and that will give us what? 0. So that leaves this expression again, right? Good. So that is exactly what I'm trying to say. That in which, in both cases, when a is greater than 0 and a is less than 0, the maximum and the minimum value of y is 4ac minus b squared over what? 4a. That is how to find the maximum and the minimum values of y. Are you with me now? Good. So we have come to the end of this class. Thank you for your time. Once again, this class is brought to you by Clever Minds, and you have a great day.